There I go.
Yeah, hi Uday.
Just hold on.
Am I audible?
Yeah, am I audible?
Little faint. It's very faint.
Oh, is it? Just hold on.
I don't know if it's from my side. Let me check.
No. No, is it audible?
A little bit better, yeah.
Oh, is it? Should have been better, but I don't know.
Now it's better, yeah.
Yeah. Yeah. So Raghav, I think good to keep your video on whenever, I think, during this session, and also
Yeah.
I would suggest that just check your screen share if it is working.
Oh yeah, it should be. Shouldn't be a problem. Right.
Yeah, I am able to see. Okay. So good. I think we are all fairly set. And so what I do is I just quickly introduce you, and then I will say that it will be about what 35 minutes session. How much? 40 minutes for you. Then Q&A.
Yeah,
Yeah,
30,
Raghav?
35, 40 minutes I think should be.
Okay.
I think 40 minutes
and
should be good.
okay. And you all set on your connectivity and all that, because in case anyone backing you up in today, in the sense for any reason, because we had a heavy rainfall and storm here in this side, at least of Bangalore,
Oh really? Okay.
Kasturi Nagar side. Yeah.
Oh, I see. Okay. Yeah, it's looking pretty cloudy, so I think it's gonna hit us pretty soon.
Mhm.
But Adi will join. Aditya is gonna be here.
Acha, okay.
If he's not joined already. But you mean internet backup? Yeah, I always keep my deep learning. So as Uday mentioned, deep learning AI has been in the news. It's been in the news for various industries, and manufacturing is no exception, right? And there are a number of use cases that we need to be really excited about when it comes to manufacturing. And one of them is really quality control and how visual processing can be automated. Right now, I just share my screen here. And before we get started, just like to quickly go around the room. People are joining in, but how many of you are actually in from manufacturing industries themselves, right? So if you're from a manufacturing industry, either industrial automation or a manufacturer yourself, just type in M in the chat window. I'd love to hear from you. Just type out M, and you just get a sense of the audience that we have. Right? So why we do that?
M is for manufacturing, right, Raghav?
M for manufacturing, that's right. So if you're from, so Satyajit, hi, manufacturing, wonderful. And if you could also mention intro while I present, it'll be also I'll be keeping an eye out on the chat window. Which industry do you fall under? So I'll kind of help tailor the presentation accordingly. So if you're manufacturing, let's say auto, then just type out auto. Which company? That'll also sort of help me tailor the discussion. Uh, what are we going to cover today in this webinar, right? So I'm going to just briefly talk about what is machine vision and the benefits and applications. So I don't want to spend too much time on, introduction. I like to show real is machine vision, benefits, applications. What are the different parts? There are quite a few elements that we need to be aware of. And it's not just a camera, it's not just AI and software. There's a whole bunch of components that go into actually creating a solution. And before you start from a practitioner's perspective, it's important to understand what are the different components that go into it. And each one has its importance and its role to play in a solution, especially when it comes to manufacturing. Right? So we'll cover that as well. And then we'll spend a little bit about time in terms of how advanced technologies like AI, specifically deep learning, and the cloud is also set to disrupt the industry. What is, the state of the art before, and how is deep learning and cloud set to sort of change the adoption of machine vision, and why is it so exciting to be thinking about this for your industry today, right? Especially how these technologies have made it much easier and made adoption a lot easier, right? So that's what we're going to be covering today. So feel free to engage in the chat window, and I'd love to hear from you. So what is machine vision? Just a definition. The machine vision is the process of acquiring digital images and computing a result to automate an industrial process, right? So it's really, we're working with digital images. So it's the entire cycle from acquiring images and then processing those images for a given purpose. What is the purpose? To compute a result. It could be any result. It could be identifying a flaw. It could be identifying, a printed character written on a specific engine, let's say vehicle identification. So, in the beverage industry or food industry, it could be reading labels. It could be anything. Finally, computing a result. In other words, you're taking a manual process which exists something like here, and you're automating whatever the human is doing, the human visual as well as the cognitive abilities of human. You're automating. So clearly, what are the benefits? And I think the benefits are obvious. It's a non-contact technology, so you don't need to really touch the object. From a distance, you can easily integrate this technology in any industry, right? Because you don't have material touching it. You can it's easy to integrate. It's speed, of course, faster than humans, and more importantly, it's not subjective, right? So today's decision making, when left to humans, becomes very subjective. You ask 5 people to classify something in an industry, you'll get 6 opinions, 6 different results, right? So here, you're always going to see consistency, be it an incorrect judgment or a correct judgment. It's going to be consistent in that. There is no moodiness to the decision making. So that's actually the biggest decision making. That's the biggest advantage, I would say, right? Which we've seen. And so, how can it be really applied? Right now, this technology has been around for decades. Machine vision has been around for decades. It's been used widely in the industry, but it's barely, it's been a drop in the ocean when it comes to adoption. But where are the applications that machine vision has today? The first thing is what is known as object detection. So let's say you have an assembly, you have an object, or you have a bunch of objects, and you want to detect the presence and absence of it. And maybe you also want to detect whether it's in the right place. So as an example, refrigerator inspection. You want to make sure all the shelves are present. These are manually assembled, and it can easily be missed out. You can miss out a shelf, you can miss out a component. And so you want a camera to be inspecting that and then identifying in a fraction of a second if anything is being missed out or not, right? So that's detecting the objects present. The second common application is measurement, gauging and measurement. So this is nothing but to measure a physical dimension. So it could be the thickness of something, height of something, right? So using a camera and an image captured from it, you can actually determine physical dimensions in microns or or centimeters or meters or whatever it needs to be. The third, and something which is now gaining popularity with AI and deep learning, is flaw detection. The flaw detections are, unlike object detection or measurement, it's something that is an anomaly. It's not supposed to be there. An object detection, it's supposed to, you're identifying objects that are present. In measurement, you're measuring physical dimensions of an object that's present. But flaws, you don't want it to be there, right? So you're identifying something that you don't want, like a scratch or some characteristics, visual characteristics, which is an anomaly. Now, this is a very hard problem to solve, technically, but thanks to technologies like AI, etc., it's actually been a lot easier. The final, not a final one, but a subset of flaw detection is print defects, right? So you have something printed, and you want to see small anomalies in the print, and that can be easily identified as well. Today, with traceability and logistics, this is something that is also coming out to be a very big adoption, is identification. Identification, technically is basically reading barcodes, and more specifically 2D codes. So you have these QR codes, dot matrix, matrix codes. Now these are something that is used heavily in manufacturing, where you want to track and trace. And these labels are read, and you use machine vision, which is a very common technology for especially 2D code.
I go quick check. Are you sharing your screen or a presentation right now, or you are not yet?
Oh, I am. Oh, I forgot to check. Is it not?
Yeah. Now it's visible. Yeah.
Oh, okay. I think I missed out on quite a few. Sure. Let me.
You want to quickly run through the earlier slides?
Sure.
Thanks.
So, yeah, we talked about the agenda, the definition, what are the benefits, the types of application, object detection, as we said, the refrigerator example, so you can see this visually. Measurement is any thickness. Flaw detection, so as you can see, flaws such as, the one you see here on automotive, these kind of scratches, welds. Print defects, identification, as I mentioned, barcodes, 2D codes, labels. So in any kind of factory assembly line, you want to automate reading of these and then taking decisions based on what was read. Common use of machine vision. OCR, optical character reading. Now, humans can't read 2D codes, so they'd like to see things printed. But is the print correct? What is printed on something, right? So earlier it was being done by humans, but now with speed and with the volume of manufacturing, you can't depend on humans. So here again, machine vision can be trained to read characters. So just like humans can read characters, optical character recognition, especially hard to read text, is also a very common application of machine vision. The next one is classification. Classification is nothing but looking at an image, and the purpose is to classify or sort. It's a sorting sort of operation. In this case, you have a bunch of SKUs for bearings, and you want to classify which part number it is based on the visual identification. So maybe common applications is to prevent mix-ups. Another example, you have different brands. You want to make sure that which brand is being packaged. It could be again classifying something, sorting. Very common use of machine vision as well. The final one, which is now getting very popular, is in combination with robots, vision-guided robotics, and the application for that is locating. So basically, you use cameras to take pictures of things moving in an assembly line, and you provide the coordinates of this location. Or could we go on mute? I think if you. So to
I request
provide the.
people who are not speaking to go on mute, please, or else I will have to also kindly people whose mic is still on. Thanks, Raghu. Continue, please.
Sure, sure. With automated material handling, the adoption of robots is becoming very popular. And so using robotic guidance where vision is actually guiding the robot on where to pick the part. So a robot can go pick a part if it knows the location. So the location always needs to be fixed, right? So then it goes there blindly and picks it up. But what if the object is moving? It's not always in that location, like you see over here. It's oriented differently. It's just coming in a very random manner. Then you need to provide sight, vision to the robot, right? And that's where machine vision comes into the picture. So what happens is the coordinate system between the robot and the vision system knows the location. So the location always needs to be fixed, right? So that goes there blindly and picks it up. But what if the object is moving? It's not always in that location, like you see over here. It's oriented differently. It's just coming in a very random manner. Then you need to provide sight. I can vision. Yeah, I could hear a little bit of a recording, but is everyone able to hear me? Okay.
Yes, yes, Raghu. Now it is fine.
Now it's fine. Okay. Yeah, just suddenly I think there was a lag. So yeah, robotic guidance. Again, a very common application which is now starting to become popular. So we've done quite a few applications where robots coupled with machine vision is starting to get adopted in manufacturing. So, but when it comes to machine vision, as I mentioned, it's not just about cameras or the software. You can see there's a whole process to it, right? And where does vision actually fit into the process? And that's important to understand. So in order to understand that, let's look at what is the process flow. In other words, how does machine vision best fit into your industrial setup, right? So you have to think about it from 4 different aspects. So the first aspect of it is what we call the pre-process automation. So in other words, for machine vision to actually acquire images consistently, you need to make sure material flow is happening in a consistent way so that a fixed camera is able to take pictures of the part in a consistent and objective way. So when that happens, then you're able to really take pictures in an automated way and then take decisions. Otherwise, if they're just randomly scattered, then you're not going to be able to image each one, localize each part separately, right? So the first, I would say, prerequisite in adopting machine vision is to make sure that you already have consistent material handling. And in many cases, especially in advanced manufacturing, large manufacturing companies, that's already there. You have conveyor lines, you have pick and place automation, you have, maybe box conveyors or some kind of material movement because the manufacturing itself is automated. So that is the pre-process to machine vision. That's why it's called pre-process automation. The next step is, in image acquisition. Image acquisition is to acquire the image. So there's no processing happening yet, but here we follow the process, the philosophy of garbage in, garbage out, right? So, and the input to machine vision is the image at the end of the day, the data. So if you feed it garbage data, you're going to get garbage results. So you need to pay sufficient attention to ensure adequate consistency and clarity is obtained during the image acquisition phase. Now there's a whole bunch of things that needs to go into consideration when designing an image acquisition system, but that is important. The next part of it, of course, is once you've acquired the image, is to process it. And the processing is nothing but software. And here software is where technologies like AI, computer vision, etc. come in, right? Now, but it's still step three. So you got to make sure the first two steps are in place before you get into this. So you can't just take AI and then plug it into your factory. You got to make sure these things are in place before you even think about, is deep learning the right technology for me? Is AI the right technology, etc. Or how do I use deep learning and AI? And then once that's done, the processing, so now you have a result. The software has analyzed the image and has come out with a result. What do you do with that result? How do you act on it? What downstream process or action takes place? And that is what is known as post-process automation. So it's either mechanical automation, which rejects the part or segregates the part or guides the robot to pick something, or uh, or it could be the what do you call it could be a software process which communicates the result to an ERP or an MES or some kind of downstream process as well. So that's the post-process automation. So what automation would you like to do after the image has been processed? And so when you look at the different parts of a complete measures, I have a nice infographic here which kind of describes all the different components that go into a whole solution, right? And I'm not going to be covering a lot of that here, but if you look at it, there is the pre-process automation. In pre-process automation, it's what is the material handling? There's a whole material handling and automation that needs to be in place. Image acquisition. In image acquisition, that's when you get into actual machine vision. You have the trigger, the camera, the optics, illumination. In camera, you have to consider the camera type, resolution, frame rate, shutter type, and then in optics, you have all these parameters from working distance, resolution, depth of field. And then there's image processing, heuristic algorithms or AI algorithms. And then there's a communication element. That's the communication that happens between the vision system and external systems, the control systems. You use communicate to PLCs, ERP systems. How do you actually communicate results? And then the post-process material handling. Now, all of these are the components which go into a solution for vision. Now, the idea is not to cover all these, but it's just to give you a flavor of the complexity involved in what goes into coming up with a solution for machine vision system. Right now, one part of it is, of course, the image processing, and this is where I'd like to just zoom in a little bit and talk about how new technologies like AI, etc., is really making some inroads and making things a lot easier than what it used to be before, right? Now, so when it comes to image processing, what is image processing? Analyzing the required images, right? Basically, that's image processing, very simple. And there are two parts to it. There's a computational hardware, which is the computer. So to process something, you need a computing device. And then, of course, the software itself. When it comes to the computational hardware, there's sort of two parts. There are two different kinds of architectures. There's external PCs, which the camera and the PC are separated. And then you have these integrated, all-in-one, smart cameras, as they call it, where the camera and the computational device are embedded, right? So, and then when it comes to the software, there's again two different distinct approaches. And there's rule-based, heuristic-based, and then there's machine learning, which is AI, deep learning, etc. It all falls under machine learning. And the primary difference between the two is really the approach to training, how you teach the system. Because for a vision system or any system for that matter to become smart, you need to teach it. It doesn't just get smart by itself. And how do you teach it? So one way is programming. You program a piece of software and the system is then able to automate something and become smart that way. So in the heuristic and rule-based approach, you're basically programming the system. So the rules are defined by the programmer. Now, in a machine learning, as the name suggests, machine learning, so the machine learns. right? So the rules are actually learned by the machine itself with the use of algorithms and learning algorithms, which is known as machine learning techniques. So let's take let's go into this with an example, right? So let's say the objective, you want to teach a machine to identify the variant of the wheels, right? So there are different 8 different variants. Let's call it 1, 2, 3, right? 4, 5, 6, 7, 8, right? Now these are all distinct. Now, when you look at it, you can see that they're all distinct. It's very natural. When a human looks at it, you know that, okay, 1 is different from 5, 6 is different from 7, etc. Some of them may be little close, like 6 and 4, but they're really, you can see the difference. So now let's say you want to teach the system to actually do this. Now, if you use the rule-based approach, you have to first identify what are the different rules that you have to program. So example, let's say you want to identify the difference between this wheel A and this wheel B. Now, the common rule is this particular area, right? This one is metallic and this one is black. So you can do this based on the color. So you program a rule that looks at, okay, check the color of this area, and if it is black, then it's this variant. If it's not, it's more closer to white, then this is variant, right? But now take the example where the color is all the same, everything's black. Now the rules get more complex, right? So now you have to look at the number of holes. So for instance, here the holes, here this has more number of holes. So you got to program something that says, okay, now I'm going to do hole detection and then counting. But then what if there are no holes? Then you have spokes, patterns, right? So it becomes complex. A simple thing which a human is very intuitively trained to do, to identify, is not so intuitive when it comes to computers and software. And this is what machine learning really set out to achieve, is to say, how can we make the machine learn as humans do? And humans inherently learn through examples. And this is where the AI approach comes in, which is basically you give it examples, right? You have all these different elements, images, and you feed it into this system. You say this is 1, 2, 3, and then you don't break your head over, okay, what rule needs to be applied to identify which variant. The system will figure that out. And then if you give it enough examples, it will become smart enough to be able to do it for future variants as well. So that's the whole idea. And basically the architecture, not to be, again, going too complex, it's nothing but a neural network. By giving it enough examples, it trains something like a neural network, which looks like this. And if you give it enough layers, it becomes very deep, and that's why it's called deep neural networks or deep learning, right? And so the process of training is called machine learning. Now, what is, and why does, some other examples basically is in rule-based, it's programming heavy, but data light. Here it's data hungry, you need lots of images, lots of examples. You need some specialized hardware and software. But it is easy to train, right? That's most important. And that's why the adoption, and it can really do things, very challenging applications. It can learn and do it very fast and very accurately, which is why AI is getting very popular. It's also important to understand where AI is not applicable, right? So AI is a great candidate when it meets the human cognitive test, as I'd like to call it, right? So basically, if you have an application and you want to think, can I replace this with AI? Then the question is excuse me, is only the human eyes and mind able to do the job, right? Forget about speed. It could be a high-speed application, but by just using human visual intelligence, can you do this process? If the answer is yes, then it's a likely candidate for AI. If the answer is no, in other words, you have to use certain specialized tools like gauges, vernier calipers, then it's probably not a candidate for AI. So, let's take a look at this example, for instance, right? So you have look at this process where a guy comes in and he's looking at something and he's making a judgment. So what do you think? Is it suitable or not suitable, audience, for AI? I hope the audience is still haven't
I
lost
think it's
them.
not suitable.
Yes, it's suitable, right? So Rohit, you're right. It is suitable because there's no use of tools. It's just literally human eyes and visual intelligence that is going into this. Now, but let's take another example where, he's doing something here. So what's he doing? He's measuring something. So is this suitable? Right. So this wouldn't be suitable because you're using a tool like a measurement caliper. So you can't really use AI to sort of replace the tool because then you have to use more rule-based techniques. Right. That's basically the idea. Now, what do we do is let's look at an actual application, right? That's, I think, more interesting, right? So let's see how AI is being used in a real world factory. And if you look at this, there's a bunch of biscuits being packed. And here the camera on the top is basically taking pictures and it's identifying whether the count or the right variant is being done. And so what you have here is you have simple to teach. So here you're just giving example-based teaching, right? No programming. And you give it labels to say which of the variant it is by using just a browser, and you're training what is known as a neural network model. And then once that's done, you can sort of integrate that with your machine to see that, this is 3, this is 2, and then it's not pick the box, right? An empty bucket is not picked a box. Only when it's 3 and it's the right variant, it picks the box. And so similarly here as well for packaged containers, when it's fully packaged, you can see that if anything is defective, it identifies it and then rejects it automatically. So that's a very common application of machine vision. What are some of the other applications? Print verification in pharma, FMCG, etc. Again, here, reading characters, making sure in high speed that the characters in the print is correctly printed. High speed label inspection. Flaw detection. So flaw detection for, taper roller bearings, basically. So you can see that something that the rollers have not been ground properly. Counting the parts of refrigerator. We saw that example when we talked about applications of the component as well as the defects. So there is a tiny defect here, which it's identifying as well. Inspection of primer on auto body. This is an automotive body. It's checking whether the primer, the black parts, have been applied correctly. OCR, tear weight of cylinders. Reading that and then communicating that to a filling station. Two-wheeler components, identifying which two-wheeler part is going into a robotic paint shop. So for traceability. This one we saw, the video. Right? Now, what I'd like to do is just pause here for a second and then see if there's any questions before I move into the next part, which is just a demo. But any questions so far in terms of
So one could unmute
We
for
have
herself.
Yeah.
So we have one question received by Mr. Emmanuel Prince Amarte. So his question is, typically in an African country, which industries can the machine vision technology be applied, and how expensive is the application? And do you have companies in Africa using this technology?
Yeah. So what are the industries in Africa that could use this? So I'll rather I don't think it's a specific to geography and I'm not an expert on manufacturing in Africa, to be honest. But the best applications that I've seen of machine vision is when it meets any of these criteria. It's either very high speed, any high speed, high velocity manufacturing inherently has flaws and defects, which is very hard to catch with humans, right? So these are food, beverage, packaging, FMCG, pharma, consumer goods, to some extent, automotive parts. So high speed, steel, great candidate for machine vision. The other aspect of it is where you have quality control is very, very critical. Like in automotive, quality is paramount, right? You have Six Sigma levels which you're working under. So it's very common for automotive industry. So I don't think there's much auto in Africa, but I would assume there's a lot of food, beverage, consumer, LPG, high-speed manufacturing that's happening, right? So those are typically great targets for machine vision. Now, coming to the cost factor, it's usually, where when you're looking at, a vision, when there is, it depends on, again, the components, right? I mentioned so many different components, the pre-process automation, image acquisition, and every application has to be customized for your specific needs. But we at Qualitas, we develop the software. For instance, we have the software and we provide that as a platform, learning, easy to integrate and apply platform. And just the software with machine vision is somewhere in the range of $10,000 to $20,000, right? But it's the services which go on top of it and any kind of material handling, which then it becomes extra. So it's really very affordable to the mid-market and above segment. No, we've not worked. We've had a lot of inquiries in Africa, but we've really not worked with anybody there. So yeah, would love to chat and see if there's some opportunity to work together in that region. Any other question which I hope that. You can either unmute or type it out in the chat. Okay, so then in that case, I'm just going to go a little bit into, what is the, how do you go, let's talk about a little bit about cloud and how the cloud and deep learning is really set to disrupt, the industry when it comes to adoption of machine vision. One of the biggest challenges with machine vision was the complexity in teaching. So you had, like we said, it's the human intelligence at the end of the day is a very complex piece of intelligence. You can't just replace with a simple tool or technology, right? There's a lot of research being done as to how you can even have a system speak like a human does, like conversational AI, etc. So it's a fairly complex problem. And so that's why in quality control as well, especially when there is slightly complex quality parameters to inspect, humans were still largely deployed and they were much more easy to train rather than replacing those with automation. And up until the point where deep learning and AI has really made significant progress in the technology. And so today we are in a space where you can teach a machine an AI algorithm, a deep learning algorithm, and have it be more accurate than humans on this production floor. And not only that, it comes with all these benefits. Subjective, they don't go on strike, they're not moody, they don't take tea and do breaks, right? And they don't complain. So now people are starting to see that benefit and say, yeah, now wait a minute, there's something to be really looked at here. And can we, take this process which we are, it's an important quality control process, it's an important visual process that we needed to employ humans for. Can we actually replace that with vision systems and then actually have that human do something else, right? And the barrier to entry was a teaching system. So what we did is at Qualitas, for instance, we built a very simple to teach AI-based teaching system, which I'll bring this up on my screen in a second. Right? Which is all browser based. So all you need is, you have existing cameras, or you can employ one of, Qualitas cameras, put them on an assembly line, and then it automatically synchronizes with this cloud applications web browser. It's all hosted on secure servers, Amazon, Azure, etc. And let's say, you're looking at this system for, identifying in the count of biscuits, right? So you see these yep. Looks like a bit of internet. Yeah. So once they get to the cloud, all you need to do is use, what is known as
Raghav, I am losing you. I don't know. That is audible.
Yeah.
हाँ बेटा
Yeah, I think there was a little bit of a lag. Am I audible now?
थोड़ा सा
Yes, yes, yes.
क्या हाँ
Hello? Yeah, while this brings up. But basically you use the browser to teach a system which is very complex and which required, I would say days and weeks of programming, which you can now do just with drag and drop and using just browser and a few hundred images as examples, right? And then doing that basically gets you is able to, let's take a look at this example, right? So this is, some images taken from, you can see on the left-hand side, it's a high resolution image, so it takes some time to load, but taken from counting cylinders. So you want to, it's an LPG application. You want to check how many cylinders are actually coming in to the plant so that you're keeping track of the count. So, instead of, it would take minutes for a human to be able to do that, right? Now you can take all these images and then just draw boxes around each of the cylinders. And then if you give it enough examples, you can go through a process that's called machine learning training. And then using that, you're able to easily develop an automated solution that can then be deployed on the edge at the plant in, let's say, this LPG cylinder plant. And it can do this automatically, right? So this, take something like this would be, consuming a lot of time. But here, go in here, you draw a few boxes, and you say this is one. Maybe give it a label. There's a red cylinder. Yeah, you want to track, whether it's a red cylinder or blue cylinder. Here's another one. This is red. So you get the idea. It's, anyone can do this, right? Requires no programming. Now you label all of these, and then you basically do a training. And the training is all in the cloud. Simple. Just click one button, and it takes about 10 hours. But then it's the intelligence is kicking in, and it's doing the training is being it's learning how to identify these. And then once it's trained, you can deploy the trained model to a PC that's on the plant, the assembly line, and it can do this in an automated way. So that's really how easy it is to develop a solution using the Eagle-i Cloud. So that's basically what I had. Spent about 40 minutes talking about various aspects, and I would like to just stop here and then take any discussions, etc., if there are any.
So Raghav, thanks a lot for this really engaging insights into how really machine vision can impact various processes and how it can really value add. Question from my side. Typically, doing a POC, right, on a business process, right, including assessing as to validating whether it is a right fit for machine vision. Who going to doing a POC with including some asking the machine learning to really do some learning, and how long would it take? What is your suggested approach? If you can throw some light on that. And obviously, to me, it clearly occurs that while this clearly seems to be that experimentation has to be there. While you will have a solution, you will have the whole AI algorithm. However, for every business process, you would always suggest that someone has to be ready with some experimentation budget, which will lead to a very I would say promising POC outcome. So if you can throw some light on that, it will be helpful for the audience.
Yeah, that's a good point. Thanks for asking that. You're absolutely right? So it's far from plug and play, and the right way to approach this is in the form of a POC, because it helps you validate what can and cannot be done in terms of your quality control automation, right? And it's always been an incremental approach. Are you able to hear me?
Yes. We can. Just that the video is slightly slow for me, but I think audio is okay. Raghav, are you speaking? I'm not able to hear you. Hello.
Hi everyone. I think we're just facing a bit of a technical glitch. We're going to be back on in just a minute.
Yeah, can you hear me now?
Yes, we can hear you. Maybe you can stop your video. Maybe it might be better. Yeah.
Internet is stable, but for some reason it just hung. Zoom.
Yeah. Now it is good.
Now it's here. Okay. So we are talking about POCs, right? And I was mentioning that POCs, yes, that's the right way to approach any problem in starting with the automation, right? And the way we actually approach the process, we call it a digital transformation journey, and um, the the process usually goes into first understanding the your specific problem area, and there's also a small I could share with you. Yeah, if you're able to see that.
Yes, yes.
And yeah, so typically it depends on um, where you are in the journey, right? So we come across various maturity levels, I would say, when it comes to adoption of machine vision, and depending on where you are, it you have to take the right steps in climbing the ladder. So in other words, first, if you're really attempting to identify where is it that you can apply machine vision, you have no clue, you're still exploring. At that point in time, you really are in the first step, and that's when consultancy makes sense. You have to really do a maturity assessment. Is my organization and team ready for undertaking this journey? Because without that, you can't really come and expect someone from outside to come and transform your organization. It has to be from within. The second phase is then going into each of the problem areas, what we call problem analysis, and identifying what is the different use cases that are potentially a target for transformation or automation, and then assessing what is the gap, team readiness here, assessment, as well as identifying target POCs and pilots, right? And then there's also the perhaps there's a training that's required in terms of you may need some understanding about the technology before you can adopt it, and that's very much required before you can adopt certain technologies like AI and machine learning. The next step is the POCs. Then it's nothing but a technology demonstration of the use case. And here you don't expect any business outcomes. I tell clients that you're just learning here. This is a practical training for you, and you really then start to realize the benefits and also the limitations. And then you're ready for your first project. And here it's a project which demonstrates a clear business win. And then once you're in that phase, then you're ready to scale. Then you see, okay, how do I deploy this across the organization? And this is the typical journey that we take organizations when it comes to AI and machine vision, right? And so it's and depending on where you stand, you may be already at a POC phase. You have all the prerequisites, and you're ready to take a POC, or you could even be looking at a pilot, because you're ready. You understand what your requirements are very clearly, and you know what needs to be done for your first application, or you could even be at scale, right? So hope that gives some perspective
Thanks.
on the roadmap.
Thanks, Raghav. I mean, it was very succinct in terms of telling us to how that whole journey has to be adopted in the digitalization of any process. And obviously, just to add to what you're saying, our observation is also that during the POC to pilot, right, that is the most important aspect of the game. Like, while technology might show a lot of promise, and however, is there a clear business win, right? These are the two steps where the focus, and even at times one has to be ready to go through a little bit of iterative process to really come to perfection there, right? I mean, I think that, but once it is achieved, I think then the scale becomes so much so easy and visible in terms of how one can adopt it at scale across either plants or regions or markets, right? I think that's
Absolutely, right. And it's not, and new technologies like these are going to go through this journey, right? You can't. Oftentimes we set expectations that you're ready. I want this whole thing to be done. I want this, but you're not ready with the first few. You don't have automation in place. Your team is not ready. They don't understand where AI, what AI does and what it cannot do. And so it really becomes very hard to work in automating something when the prerequisites haven't been fulfilled yet. So it's very important to understand that and at least come to a POC stage before you're ready to get into an actual project. Otherwise, what happens is you're just churning a lot of time, looking at high budgets and high complex problems, not clear on what can and cannot be done, and it doesn't go anywhere, right? So you don't come out with anything. So you're just spending a lot of you just spend a lot of time and energy into it, but without any outcome.
Thanks. Obviously, I think this has been very insightful, and I'm sure people, for whatever reasons, shown interest, and they would be surely getting the on-demand video as well. And I'm sure that would further get more people interested to venture more and more. I really appreciate Qualitas, and especially you and your team's prowess in terms of getting into the details of your process, including the various machine vision equipments which you have designed and curated and all that. I am sure having worked earlier, I've seen that those are a very clear USP of yours, and that I think helps in terms of building up a use case and a POC for any complex process, which is first of all a fit for machine vision. So I believe that this USP is something which you should continue to, others should continue to leverage on. I think that is the differentiator. I personally feel that what Qualitas carries, right?
Yeah, thank you. We believe that as well. We've been doing this for a couple of decades now, and then we've learned quite a bit, especially through this journey. So excited to engage with anyone in your network, Uday, and see if we can translate some wins for your customers.
Absolutely. Thanks very much. I'm giving a last minute in case anyone has any questions. Maybe an Andrila, if there's any questions in the AMA, if you want to check. Otherwise, I think we are all sorted and good. Oh, yeah.
We have another question from Mr. Emmanuel Prince. His question is, who are the major companies in India with machine vision technologies?
Yeah, and in providing machine vision technology or using machine vision technologies.
It's providing.
Well, yeah, I mean, see, you have different machine vision is a very broad range of solutions and products. It's been around for decades, right now. So on one hand of the spectrum, you have what is known as the smart cameras and vision sensors. They're very basic, low-cost devices with embedded vision and software algorithms, and those typically adopt, rule-based technologies, which I explained rule-based in AI. And there are a number of, you name it, there's SICK, Panasonic, Cognex, Banner, Omron, Datalogic, Baluf, Wengler, PNF, you name it, they all have these vision sensors, machine vision technology. Any of the large automation companies, right? And then as the complexity starts to increase, then you start to see specialized players. So then you start to see more specialization in terms of companies that only provide cameras, for instance, image acquisition. So then there are companies like Basler, Teledyne Dalsa, Imaging Source, and they only specialize in providing image active cameras. So these cameras are only acquiring images and then providing those digital images to a piece of software. And then there is ancillary units, which the optics that come in. So because the cameras are just the imaging sensors, you have to have optics and lighting as well. So then you have all the usual suspects: Fujinon, VST, Edmund Optics, a bunch of others, and specialized players like Opto Engineering, etc. And they're all present in India. They're all present in India. I'm talking about they're foreign companies, but present in India. But when you talk about Indian companies, then you start to see a lot of players in two different segments. You see integrators, system integrators that take all these different components and integrate to form a solution. And then you have companies like ours who also develop the software. So we manufacture the AI software. It's a product that we developed. It's called the Eagle Eye. And I believe as of now, we're the only one that's Indian based who are providing this platform, which is suitable for a browser-based platform, which you can use and sort of use it as a product. And other players also, which are present in India, again, Cognex, they acquired a company which does these deep learning software as well. It's a US company, but present in India. And a few others, right? So that's how the ecosystem is in India.
Thanks, Raghu. I think the clear differentiator obviously is your AI capabilities and your domain capabilities, which adds to the simplification of this whole deployment of AI. Is what I feel. I think is pretty good in terms of being focused in your area of work, and appreciate that. Great, thank you so much today.
Thank you, guys.
Aditya and Raghav to come over and really have this complete I would say academic session, but this was so insightful in terms of how people should approach towards this whole thing, and I'm sure people referring to this video would surely get more and more ideas as to which are the business processes they should look at and build up an internal case. And obviously, I would urge people to really go through this again, and happy to connect with you. You have your, you can connect me at incubatehub.com, or you could connect with Raghav. If we can give your email ID, Raghav, there, that should be also good enough.
Yeah, I'll type it out in chat box for anyone who wants. Yeah.
Thank you. Thanks.
Thanks, guys. Have a good evening. Stay safe, everyone. Bye-bye.
Yeah.